Okay, we're going to continue with packet 2 today. We're going to talk about probability, but we're going to talk about independent and dependent. Okay, dependent and independent. Now, the dependent, it looks like a lot of these are dependent, which means that what happens the second time, like the second roll or the second flip of a coin or the second time you draw something out of the bag depends on, the probability of that depends on the probability of what happens the first time. Okay, so let's just look at number 1 and let me explain that. Okay, number 1. Okay, for those of you on remote, it says that there are 10 cards numbered 1 to 10 in a box. The cards are shuffled and they're drawn at random. Okay, here's the problem. It says 3 cards. We're going to take out 3 cards, 1 at a time, okay? And we're not going to replace them. When we draw them out, we're not putting them back. That's what this number 1 says. Okay, they want the probability. If the numbers on the first and second card are 4, so they're telling you the first one has to be a 4. The second card has to be a 6. They want the probability that the third one is an even number. Okay. Now, remember, we're going to draw. Let's do this. I'm going to show you visually because sometimes just thinking it in your head is difficult. And so what we're going to do is I'm going to have these cards. There's 1, 2, 3, 4, 5. They're in a box, and 6, 7, 8, 9, and 10. Okay. So I think it says through 10, doesn't it? Yeah. 1 through 10. Okay, or in this box. So what it says is I want the probability that the third card is going to be even. Okay, well, what is the probability that I'm definitely going to reach in, and I am saying I definitely got a 4. Okay, I definitely got a 4. What was the probability that I got a 4? When I reached in the box, I got a 4. What's the probability? There's only 1 4. I'm just doing the first draw. So there's only 1 4, so the probability is 1 chance.
1 out of 10.
Okay, so the probability here was 1/10, right? And I got that, they're saying, and I did not put it back in the box. This is no replacement. So the 4 is gone. So what is the probability? Let's do this. Getting a little messy here. What is the probability that the second time I draw, I'm going to get a 6?
1 out of 9.
1 out of 9, because there's only 1 6 there. Okay. So 1 out of 9, because I only have a total of 9. Now we got the 6. So now what is the probability? I took the 6 out and I didn't put it back in. So now what is the probability that I reach in and the card that I pull out is an even number?
3 out of 8.
3 out of 8, because here's an even number. That one's gone. So the probability here is 3 chances out of, there's only 8 possibilities because this one and this one are gone. So 3 out of 8. Now I'm not sure. I think, let's look at the answer. I don't know if it's 3 out of 8 or we have to multiply these. 3 out of 8. The probability of getting An even number on the third draw without replacement is 3/8. Okay? Do y'all understand why? Okay.
Not really.
Yeah, because you've missed some probability a little bit. Yesterday, you were kind of on your medicine, right?
No, I didn't take any of those today.
Okay, now, number 2 tells us if the conditions are the same here, they're the same, find the probability of choosing a prime number on both the first and second draw, okay? So here's what we need now. They're not even talking about the third draw. They just want the first and second. And both of this, it says, and it has to happen on both of them, okay? So they want a prime here, the probability of a prime here, and then a prime here. They said everything is the same in the instructions. So when I draw a prime here, I'm not going to put it back in the box. So let's erase all the circled and stuff that we have. We're starting again with our box full of 1, 2, 3, 4, 5. Now remember what prime is. Prime means it only has exactly 2 divisors, 1 and itself, right? And we found out that 1 is not a prime, which was news to me too. 9 and 10. Okay, we want primes. So what is the probability if I have all these possibilities, I put my hand in and draw out a prime the first time? So
Are they only able to pull out one?
right now, we're going to pull out a number and it has to be a prime.
Okay.
And then we're not going to put it back in and we're going to draw again. And it has to be a prime both times.
Okay, so we're only drawing one time from each one?
Yes.
Okay.
Yes. So here's a prime. Here's a prime. Here's a prime. Here. That's it, right?
Mhm.
So I have 1, 2, 3, 4 chances out of 10. And 4 out of 10 simplifies to 2 out of 5. Are you guys okay with that? It was 4 out of 10, and then I simplified it. Okay? Now, I took it out. And there's no longer that card there. Now, it doesn't matter which one I pulled out, but I pulled out a prime. So I'm just going to mark one of the primes out. Okay? Now, I'm going to put my hand in there again and draw out, and I need the probability that it's going to be a prime again. So how many primes are in there now?
1 out of 3.
There's 3 out of them. So there's 3, and there are only 9 in the box, right? And that simplifies to 1/3. So, Deborah. So what I was thinking is that we have to multiply 5 because that has to happen and that has to happen. But that's not the answer. Oh, another one of Deborah's days. I'm going to pause the recording while I figure this out so y'all don't have to sit through this. Okay, rewind. When I worked this problem, I took part of question number 2, where it said we're not going to replace and everything's the same as the first. But then I skipped to part of number 3, which said I'm choosing a prime number on the first and second, which means the answer didn't come out like it was on the worksheet. However, every bit of this work here is true, and the answer is correct for what the made-up question was, okay? So this is true, and this is how it's done, okay? This is correct. It just didn't happen to be a problem on your worksheet,
Okay. Oh.
okay? See, I took part of number 2, and then I started reading number 3, and so we made up our own problem. But the answer is correct for the made-up problem. So good, I didn't have to go back and I thought, oh, good, your math teacher's crazy. Okay, we're going to do all of number 2 now. We're going to do number 2 on your worksheet the way it is
No
written.
wonder I was sitting there looking at the paper. I'm like, where is it saying this?
Oh, yeah. Oh, yeah, and you guys are so sweet not to say, are such.
I was like, yeah, I'm gonna get it today.
It is all, everything was right for what I made it up. Okay, I'm going to read the whole thing. If the conditions are the same as in question 1, here and here, find the probability of selecting an odd number on the third, okay? On the third one. So here's the first time I draw. Here's the second time I draw. And here's the third time I draw. This is the one they want. But we need to look at the first and second draw because we are not replacing the card when we do these. Okay? So our box contains 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 again. Now, the problem does not say anything about the first and second draw, does it? We're just going to draw a card and not put it back. Yeah?
An odd card?
Any card, because the odd is on the last one.
Okay.
They don't say anything about the first one, right? So on the first one, I want a probability of picking any card because they didn't specify. So what is the probability of picking any card out of that box?
9?
Any card. How many cards are there?
Oh, 10.
Out of
1. 1 out of 2.
because I can get any of them and make it true, right?
Yeah.
And that equals 1. Okay. Now it says no replacement, so I took it out, threw it away or whatever. Now, what is the probability? They didn't say anything about the second card. So what's the probability of getting any card? 9 out of 9. And that simplifies to just 1. Now we're at the important one. I'm going to read it for sure again. Find the probability of selecting an odd number on the third draw. Okay, this could be interesting because we have pulled out numbers. I don't think they're thinking that hard. They are. Okay, I know since I didn't put this one back and I didn't put this one back, I only have 8 cards. Is that correct?
Yes.
Okay, I only have 8 cards. So the probability of getting an odd, I don't know how they're doing this. 1, 2, 3, 4, 5. These are the odd numbers. 1, 2, 3, 4, 5. Okay. And that's why they're getting 5 out of 8. Now I have to take a side note and say, if I picked out a card here, I really have to mark one out, right?
Yes.
What if it's an odd? Or what if it's an even? So this probability isn't, this problem isn't as clear, but they're just wanting to know if I did any one here, that's one you know, I am definitely going to get a card.
Since it says if the conditions are the same as in question 1, shouldn't we go ahead and leave the 4 and the 6 out? Because
Girl,
It does say that.
that's why she did so good on her practice test. You'll have to ask her how well she
That's
did.
how you got it.
Yes.
That's how you got the 5.
Okay, so what Sandra is telling us, it says if all the conditions are the same as in number 1, then they picked out a 4. Right? But it could have been any number. Any number. Let's leave it like that. But in number 1, they took out the 4 the first time. Okay? And then what's the probability of getting any number? That was still 9 out of 9. I could have gotten any of them. But in problem 1, they took out the 6. Okay? Sandra, you're awesome. So again, on the third draw, we want the probability of getting an odd. We know we only have 8 cards left, and none of the odds were taken out. So 1, 2, 3, 4, 5. You guys are geniuses. You get to teach tomorrow. So 5 8s. Are you guys with me, or have I totally just wiped everybody out?
No, I'm still with you.
Still with me?
Yeah.
No, okay. I love you guys so much. Okay, now we're going to number 3. You've already done part of number 3 when we did the weird problem, but we're going to do problem number 3. Number 3 says, and still we're working with the 1 through 10 in the box. If 2 cards are drawn with replacement, that means when I draw it, I put it back in the box. Find the probability of choosing a prime number on both the first and second draw. So I'm going to draw 2 cards. Here's the first one. Here's the second one. And I'm going to replace. So when I draw, I'm going to put the card back in the box. Okay, so they want the probability the first time I put my hands in there, I'm going to get a prime. I hope I'm remembering correctly. Prime number on both of them. Okay, the first time. What's the probability of getting a prime when I put my hand in that box? We need to know how many primes there are. There's 4, 2, 3, 5, and 7. You are correct. So 4 out of
10.
Okay. 4 out of 10, which becomes 2/5. Okay. Okay, now the second time. Okay, it doesn't matter which prime we took out of there, but we did take out a prime. It doesn't disappear because we put it back in. So now we still have 10, right? So what's the probability of getting a prime the second time?
4 out of 10.
You're exactly right. Yay. So it's 4 chances out of 10 again, because we have 10 cards. And is it 4? Yeah, because we put it back in. 4 out of 10, so 2/5, right? Now, if both of those have to happen, that's an and. They want to know if you get a prime on the first one and a prime on the second one. And if you go back to our first day of probability, and means to multiply. Means to multiply the probabilities. So we're going to multiply this. And so the probability of both of these happening exactly like they say is going to be 4 chances out of 25. Please tell me the answer on the back is correct.
Yes. I think I saw it a minute ago.
Okay. Now this one, you're going to have to. Sandra, you're going to have to help me with this one. Okay. This one says, if two cards are drawn and we're not going to replace, if two cards are drawn and we're not going to replace, find the probability of drawing a 4 or a 5 on the first draw and any prime number on the second draw, which is giving me a problem now. Even prime number, not any. Okay, this one's a 4 or a 5, okay? So what's the probability, putting my hand in the box and getting a 4 or a 5?
2 out of
2 out of,
10.
right? 2 out of 10 equals 1 out of 5. Is that what you said? Whoever said that. But my problem is, oh, nope, that's not my problem. Okay, so I either marked out one of these, doesn't matter. Okay, now it says I took it out and this isn't there anymore. Now, what is the probability of getting any even prime number on the second one?
It would be 2 or 3.
3 isn't even,
Okay.
2.
so we've got 2. Huh.
Just 2.
That's it, right? So the probability of an even prime that's left over, tell me one more time.
2.
Well, the
1
2
out of 9.
one, so that's 1 card, right?
Okay.
So 1 card out of
9.
9 cards, because we did not put that one back
yeah.
that we drew here. So we found out that if we want both of these to happen exactly like they say, then it's an and. This has to happen and that has to happen the way they said.
6 isn't it even?
It is even, but it's not prime.
Oh, prime. That's
Okay.
right.
And so if they have to happen like this, then we're going to multiply. And so the probability of these happening exactly the way they say is 1 chance out of 45. And if I translate this, then we could actually do an experiment and we could put all those numbers in a box and we could actually pick this stuff out every time, 45 times. We would have to try it 45 times. And in all of those times that we tried, this combination would only happen once. That's what this is saying. Out of 45 times that I keep drawing and I write down what I got, keep drawing and write down what I got, this estimate is that it would only happen 1 time in those 45 times that you tried. Okay, do you understand it? All right, we finished all of page 1, aren't you glad? Okay, so you get the idea. We're not going to do all of page 2, but I want to look through this. Okay, I think you can do page 2. I'm going to leave you to it. Let's do page 3. Now, page 3 is simply talking about what factorial means. What does factorial mean? And you're going to use this factorial. I used to say factorial. Factorial simply means, let's say for an example, 4 factorial. This is the symbol for factorial. The exclamation point. And what this means when you see it is it starts with the 4 that's given and it's multiplied all the way down to 1. And so the answer to this, when you multiply this out, is going to be 24. So the answer to 4 factorial is 24. Okay? What's the answer to 3 factorial? 3 factorial.
Oh, it would be,
19?
it would be 6 times 1 is 6.
3. That's 6.
3 times 2 is 6 times 1 is 6. That is 3 factorial because you start with the number given and multiply all the way down to 1. And then you multiply it out. Okay? So one more time, y'all. Do 5 factorial. 5 factorial. And tell me what the answer is. And then I'm going to show you how to do it on the calculator.
Hundred and 20.
120. You start with the number you're given, go all the way down. But what happens? And I tell you to find the answer to this. How much fun is that going to be? 32 times 31 times 30 times 29 times 28 times 27 times 1. Okay, so your calculator will find
I
this
was gonna
for
say,
you.
Will you ever use the calculator?
Blah, 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 blah. Okay, so on your calculator, this is the one that we use in the classroom. Go to the top and right underneath, well, it's in the second column, the second button down, it says PRB. Now that all has to do with probability. So all of that stuff is in that menu. Oh, clear this. Okay. Right here is the probability button. Right here. PRB means probability. So if we push that, we can see all the different things that we can do with probability. We're going to use all 3 of those. I'm not sure if I'm going to, might wait till tomorrow to do the first 2, but see that the bottom one is that exclamation point. Do y'all see? Okay, that's factorial. So let's clear out of that a minute. Okay, clear. And now I want you, let's do the 5 factorial in the calculator and see if it's the same answer, okay? Now the way you use this, you got out to a clear screen because you have to put the 5 first. So we're gonna push the 5 first, then we need that exclamation point, so you go to the probability button to get it. You can either scroll down and press enter, or you can actually push a 3 and it will choose it. There's 5 factorial, and then you just press your enter or equals. And your answer is right here, 120, which is what we got, 5 factorial. So I wonder what 32 factorial looks like. It's probably going to be in scientific notation. That's okay, I'll help you. Yes, huge number. This is scientific notation, 2.63 times 10 to the 35th, which means you're going to have to move the decimal where it is, between the 2 and the 6, so you're going to have to move it 35 times to the right. So it's a huge number, okay? And we knew it would. I'm going to go help in the class a minute, so hang on.
Oh, got it.
You did?
Yes.
Okay. Now I want you to do, let's try both of them because we don't know if you're going to have to do it by hand. So I'd like for you to do 7 factorial and do it by hand first. Okay, I didn't give you a big one. 7 factorial. So it's going to be 7 times 6.
So are we doing 7 times 7, 7 times 6, 7 times 5?
No, you're doing exactly what's here. 7 times 6 times 5 times 4. You're putting it in your calculator, just like this.
Okay, we're going to do it by hand.
Well, I meant don't use the factorial in the probability yet. That's what And then when you're done, when you multiply, then try it with the probability button and see if you, I'm guessing. So we have 7. A little bit. So no matter which way you did, whether you multiply these all across or you use the probability button to get the factorial. Are we good?
Yes.
Looks like Luanny got kicked out. All right. Now I want to show you something, and you're not going to. Okay, on that page. On this page at the bottom, it might be a little misleading, so let me clarify something. On the bottom half of this factorial page that we're working on, the bottom part says 83, and it has a period, okay? They're just saying we're multiplying all of these. I don't know why they do it like that. And then it has dot, 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 and then it has this and this, which looks like 2.1. But what they're saying here is they want you to write this series in factorial form. They're saying if I start with 83 and I multiply all the way down to 2 times 1, that's how they're writing it here. A little bit confusing, but how would you write that in factorial form? And you would write it, factorial form is simply 83 factorial. That's what they're wanting on this bottom part. Y'all see, these are confusing when I first looked at them, and this looked like 2.1, but it's not. It said we're going to go all the way from 83 down to 1, is what they're saying. Does that clarify the bottom part? This is what I'm talking about, is the bottom part. A little confusing, but we just wanted it expressed in factorial form. Okay. Now, I want to show you one last thing about factorials, and I don't think we're going to go any farther today. I was going to go ahead to combinations and permutations, but let's just do that tomorrow. And that way I can answer some questions if you have any. So let me do this. What if you had a problem that said 7 factorial divided by 3 factorial? Well, you actually could do this in your calculator, do this in your calculator, get the answer, But what's actually happening, and this might help you later when we start to put variables in here instead of just numbers, by longhand, this would be correct? That's what 7 factorial is, but 3 factorial looks like this. Right? So you can see that the 3's will cancel, the 2's will cancel, and the 1's will cancel. Okay? So if you have this idea in your head, you might be able to develop something that helps. You can actually do it here. You can do the 7 factorial. Okay. We're going to do 7 probability factorial.
Which one's the factorial?
The third one.
3?
Uh-huh. Did it
It
go
goes
7?
7.
Okay. But don't do anything there. Don't press enter because we're going to make a fraction out of it. So push your little fraction button. That should put that on the, no, it's not going to.
I
And
have it.
did the 7.1 go in?
No.
I mean, the 7 factorial, it didn't go.
I just have the
It should have gone to the top.
Oh,
That's what.
okay.
Okay, so let's clear that. So the way you would put this in the calculator would be 7 factorial. So 7 probability, the third choice, and you have that on the screen, divided by 3
So
probability factorial. And then that would give you the 840 that this will. This is 20 times 42, which would be 840. Because these canceled out.
what I got the same answer, but I did the top, did the 7 and got 50/40 and divided that by the 3
That's okay. That's okay too.
or by 6, and I got 840.
That's okay. This is what I did in the calculator here. We tried to put it in this little fraction button, but so far I haven't figured out how to make that thing work. So our fraction line means divide, so I just put it in as a divide. Okay?
Okie dokie.
So I could push you guys to permutations and combinations, but let's not. Let's just do those one. We did the first page all together, but you can go through and try it on your own and make sure you still understand. And then page 2 is similar to page 1. And so you're going to do those. And then the third page has to do with factorials and just making sure that you understand what a factorial is. Look at page 4. Yeah, try page 4 because that's doing these operations with factorials. And then tomorrow, we'll start on page 5, permutations. Sound good to you guys?
Yep.
And let's see, is Luanny back on?
Yes, ma'am.
Good. I don't know how long you waited, I'm sorry.
Oh, no, that's fine. I get it, I guess, but I don't, but I guess. It's kind of hard for me.
It's brand new, and so it'll take a little bit of work. We'll talk about it again tomorrow.
Okay, thank you.
That sounds fine to me. Do you have any questions on yesterday's, or do you just want to look at the YouTubes and then ask questions tomorrow? Which would be better?
I'm gonna look at the YouTubes again and go over and see.
And Rachel, I would suggest that for you too. Go clear back, I think it's like 2 days before today. And you guys have been in class, but you may want to look at the YouTube also. It's up to you. Other than that, I'm through for today. We start on packet 2, page 5 tomorrow. We're going to work on permutations and combinations. Be sure and bring your calculator again along with that worksheet, and I'll show you how to use it to find all of the answers. They'll be quick because you'll do it just on the calculator. Okay?
Okay, thank you.
Love you bunches.
Oh, I love you, sir.